Manufacturing Unscripted. My guest today is Greg Lynn, CEO of Piaggio Fast Forward. We talked about Greg's history as an architect and how it led to his role as a co-founder and CEO of PFF, as well as their mission to integrate robotics that follow humans either in their personal lives or in the workforce. We hope you enjoy.
This podcast is sponsored by Promus Incorporated, the leading provider of fully electric servo presses for manufacturing. Promus provides global support for pressing and motion control applications in multiple industries. With precise positioning and in-process force monitoring, your company will begin to see ROI on day one. Call 810-229-9334 or email sales@promusinc.com to speak with an expert engineer about your application today.
Welcome back to Manufacturing Unscripted. I'm your host, Peter Parsons, and today I'm joined by Greg Lynn, CEO of Piaggio Fast Forward. Good to have you here, Greg.
Oh, thanks for having me, Peter. Looking forward to it.
Yeah. So would you be able to, just to start us out, introduce yourself, who you are, who PFF is, and kind of how we got here?
Sure. So I'm the CEO of Piaggio Fast Forward. We founded the company just a little over 10 years ago in Boston, Massachusetts. Along with the two other co-founders, my role for the first 5 years was as Chief Design Officer. And I'm sure we'll talk about kind of what I would define design as. But after several years, as we moved from more R&D to producing products and selling them out in the real world, I transitioned over to being the CEO. And Piaggio Fast Forward, we build robots that move goods. We have a consumer business and also an enterprise business. But much more than that, we build robots that safely operate in extremely close proximity to people, in, frankly, the proximity that every other robot stops moving is really where we kind of start.
Okay, yeah, and because I think a lot of automation these days kind of looks at robotics as a way to, either replace people or, take the place of operators. And this is kind of less so, a replacement and more so almost like a tool to assist people.
Absolutely. I have to say, I always cringe when I hear robotics companies say, we're trying to do the dirty, dangerous, boring, repetitive work that people do, which is kind of a soft way of just saying we're looking to replace people. And for us, we always want to help people do the things that they're good at and help people do the things they like to do. Maybe taking some of the burden away, but helping them just do things faster, more efficiently, healthier. But we always are looking to augment and be with a person. And that poses a lot of significant challenges. But that's really the challenges we're focused on, is how to be with people in a way that's helpful, productive, and safe.
Yeah. Would you be able to maybe give some examples of kind of what that looks like in terms of, assisting people?
Sure. Well, so we have the ability to both travel autonomously and also travel with a person. And when traveling with a person, it could be as straightforward as following them, like predicting where they're moving, taking cues from them. At a hardware level, we always make our hardware to have similar performance as a person. So the robots can accelerate as quickly as a person can. They can decelerate as quickly as a person can. And we could talk more about kind of the data sets and algorithms and AI we use to do that. But we really focus on pedestrian etiquette. So if a person is at work, how quickly do they move when they're in open space? How how much do they stop? And what does that look like when you're stopping? So the robot is not just twitching around and getting in the way just because you're moving back and forth performing a task. We really focus just on how to accompany people and interact with them in a way that takes no training, that's the same way a person would behave so that you understand intuitively how to interact. And that way people also accept our robots. When wherever we go, frankly, people are excited and engaged because they're not afraid, and what we have is very predictable and familiar, even though it's totally new. And it even to bystanders, we focus as much or more on the bystanders that are seeing the robot as we do the people that are interacting with it, just so they're acceptable, like in a workplace.
Okay, so it's maybe more so, taking this system, taking this robot, and finding a way to integrate it into kind of our existing, like our pedestrian structure, navigating without necessarily creating its own channel of communication and transportation and things like that.
For sure, for sure. We want to not have to necessarily change workflow. We don't necessarily want to have to retrain and restaff. We for sure don't want to have somebody like grind their floors down so that our robots can move on them. We don't need to do any mapping. Our robots generate their own maps as they move. We don't ever assume that somebody's got like a robot wrangler, like some engineer that's running a Mars mission in a manufacturing facility. And that way we can have automation that's very dynamic and flexible. And most of all, we want it to be so easy to use that you don't even have to train someone on how to use our robots. They're absolutely simple, don't need any explanation, and people can be running and working with them with the workflow they're already using, just 20% more efficiently within like 5 minutes.
And I imagine, kind of as one of the co-founders, being with this project since the beginning, were there a lot of kind of struggles or hurdles that you really weren't expecting? Kind of going into the development, something that maybe was not even a consideration just when it comes to basic, navigation following humans.
Sure, sure. I mean, I think a couple of things. One is, and this is a cliche, I mean, for a reason, because everyone knows it. If you want to build a technology that's simple and easy to use for everybody, that's the hardest path. It's very easy to make a complex, complicated solution. And for me, as the leader of our teams, I'm always asking, is this feature absolutely necessary? Like maybe you're an engineer and you would love to be able to spend a lot of time on a screen, moving this robot. But who wants that? Does our customer want that? Do the workers want to do that? Probably not. What they're going to want is something efficient, easy to use, reliable, predictable, and doing that is really much harder than making something complicated. To introduce a person into the loop is obviously also a lot harder. That's why all of the automation in manufacturing and logistics started off in cages because interacting with people is a hard problem. It's the hardest problem, frankly. So that's also been a huge challenge for us. And again, it's not just being safe. It's actually being understandable and acceptable. Because there you hear this term cobots. Cobot just really means it's a robot that's not in a cage that won't hurt you. So, and that's good. I mean, we don't want robots in cages and we don't want robots hurting people, but a cobot if you look at the companies that have been using that term for the last few years, they just mean safe robots, like that they can avoid obstacles, they can brake and detect people in a reliable way, and that nobody's going to get hurt. But that doesn't really mean that workers are going to interact with these things um, in the normal flow of their work. They're going to show up and do a task and then go away. They're not going to actually be accompanying a person or assisting them in any sustained kind of interaction.
Yeah. And I know I've been in different factory floors and manufacturing environments where they will have that kind of introductory level of automation where there might be a cart that's driving parts around autonomously. However, it has this big LED display on the ground that's, don't get within 5 feet of this.
Yeah.
It's got big signs on it that's like, stay out of this thing's way.
Yep.
And it's like, it's an introduction of the technology, but it's still, there's still so much that it needs to go through that, you have to be wary of it. You have to stay away from it. There's not that human connection. It's still very much a foreign presence in an environment.
Yeah. And if you think about the kind of cultural imagination of science fiction, there are always like two kinds of robot. There is the robot which has an implicit menace to it because it does not understand people and it moves around and interacts with people, but it's not something you necessarily trust, let's say. And then there's the other kind of robot, which is like the little buddy sidekick, which is going around with people all over the place. And, we're definitely that sidekick version rather than the super machine that nobody understands what its motives and operations are.
Yeah, definitely. As a big fan of science fiction, that's kind of immediately where my mind goes a lot of times, when people talk about just robots in general, but especially, anytime you're pushing for robots to be, integrated with people, incorporated into people's daily lives. Just that question of, is this a robot that has its prime directive and it doesn't care who it hurts in order to accomplish it? Or is it kind of maybe more like the classic like Asimov robot where, it cannot hurt humans. It must do what humans says. It has this very strict set of rules.
Yeah. Well, I mean, it's those directives are great. It's a pretty low bar, though. It was very funny when we founded the company. It was initiated by Piaggio Group, which is an Italian manufacturer of 2- and 3-wheel vehicles primarily. They do some small trucks as well. But the brands they own are brands like Aprilia Racing and Moto Guzzi motorcycles and Piaggio motorcycles and scooters. But primarily the brand people know in the States is they own Vespa scooters. And in this first meeting where I was just invited to come talk to them about the future of mobility and automation, there were maybe 8 people, and I think 6 of them all suggested, this is 10 years ago, that they should build an autonomous scooter to deliver pizza. And I understand because they're an Italian company, they thought pizza delivery, but they every person that gave a presentation suggested the same problem to solve. And at the end, when a lot of the people left, the CEO and president of the company, they turned to us and they said, this is a terrible future. Like, we're in the business of improving the quality of people's lives. We make products that people aspire to own because it's going to give them freedom and pleasure and friendship and experiences. And what everyone here in Silicon Valley seems to be suggesting is that my kids are going to sit on a couch looking at a phone, ordering pizza, and your problem is, how do I get the pizza from the curb into the house? And this just sounds like a future we don't want to be involved in. And so I really think that, yes, we don't want to hurt anyone. We have our prime directives. But we also want to improve the quality of people's lives, whether that's in the workplace or for people, where they live and recreate and socialize. We always want to make their lives better. And that doesn't mean by like taking things away from them that they need to do, like folding clothes or doing the laundry, which that's all great. I mean, I think I can't wait for that. Same way it's nice to have a robot vacuum. But we actually want to improve people's lives by making their activities better rather than taking away the activities they don't want to do. And frankly, there aren't a lot of robot companies that start off with trying to improve the future. It's much more just taking away some of the negatives. But that's not really improving. That's just taking away, things that are not what people want to do. We want to be with them when they're doing the stuff they need and like to do and are good at doing. So,
Yeah, and I think it's interesting too because when you're looking at like a workplace, it's very easy to look at it and say, I think you mentioned this earlier, like, oh, we can get rid of the dirty manual labor, the stuff that nobody wants to do. And in that sense, it falls under this category of, these are things that need to get done in order to produce something, create the goods and services. However, a lot of people might kind of take that innovation and try to just directly transplant it to, the modern life. And I think it's pretty much what you were saying where, we can eliminate some of these tasks that people have to do. But, what's the extreme of that? What's the point where if robots can do everything for me, then what's the point of me being here? And sometimes that's where you lead into that kind of dystopian, humans become obsolete in the world.
yep. Yeah, and it's I think there are a lot of big steps happening now. I mean, one of them is that memorizing where every part and piece is in a manufacturing facility or in a logistics facility is not something a person can do. So, uh, you know, the a database localized in a digital twin of a place, that's a superpower. That's not something that a person has. The next step then can often be, well, so now what's my job? My job is following a robot around, which knows where things are, and it's going to shine a light on something that I need to grab, and it's going to shine a light on some place that needs to get it located and assembled. And so all of a sudden, like you're working for a robot. You're a partner with the robot, but like it's not that the robot is supplemental to the work you're doing. It's you're just helping the robot do some of the stuff it can't do yet. And I, I don't quite know what to say. I mean, I'm very excited about those technologies where people and machines are working side by side. But like you're saying, it does a little bit hint at a future where maybe that robot doesn't need that person anymore. And so if your boss is a robot and you're following a robot around, picking and placing things, um, that that might not have the kind of job security people want to have.
Yeah. And, there's kind of the two options where, one of them is, the implementation of robotics. It allows people to kind of improve their efficiency, have much more impact within their jobs because they're not bogged down by kind of the tedium of their day to day. But then there's the other side of, there's a lot of people whose job is explicitly that tedious labor. And once that's been replaced, is there a position for that person? Is there a suitable upgrade once they have this, tool that's able to provide the level of efficiency that it can? And
Yep.
I guess maybe more on kind of a philosophical edge, do you think that that's a responsibility that should be kind of held by the companies that are providing these tools? Or do you think that's more of something that kind of we as people need to kind of make a decision on?
Well, I mean, I think that companies like ours, it's our job to try to give good options to companies whose primary obligation is to their shareholders. And at the end of the day, that's how they're going to make decisions. So for us, we try to make a proposition for return on investment. So say you're in a manufacturing facility making really big objects that move on a mile-long assembly line, and they're just creeping along, a fraction of a mile per hour. So everything, tools have to move, desks on the floor have to move, point of use carts aren't in stable positions all the time. Sometimes they need to move. So in those places, you see a high level of automation, but you also see literally tens of thousands of carts being pushed around by people and, um, tools having to move from place to place and very intelligent people that are looking at the process and figuring out where to make like a quick trip or convey something that can't be conveyed in a normal way. And you really do need those people. That's not a job that can be automated, at least now. So what we can do is come in and say, look, you don't have to rebuild your factory. You don't have to install, new fixed equipment. But, with several hundred of our robots, they can both follow people on trips, and if there's motion waste of them having to go back to another point, just anybody with no training can record a trip and map the environment today, which is changing minute by minute, and our robot will be able to move back and forth, but not with an engineer programming a path, but with a person. So that person, we try to make our stuff easy to use so that that person who's now interacting with automation isn't losing their job and having to figure out how to program a robot. They actually can work with the automation and use it in a way without having to become an engineer. So both the idea that we kind of work in the real world today without having to make a new environment for our robots, and they're easy enough to use that everybody could use them. You don't need any training. You don't need any special experience. It lets automation go into the world in a way where people are more engaged with it and they're not having to completely change their role or responsibilities or the environment they're working in.
Yeah. And especially when at times a lot of companies are really moving into this like hyper specialization where, you have this isolated cell where, people set it up, people programmed it, and it's going to do exactly one task. And it can do that one task, extremely well, extremely quickly, but there really isn't that ability to, adapt and easily modify itself to either a change in needs, a change in process, anything like that. So at least in terms of, these robots that you guys are providing, they have that, adaptability as part of their core functionality.
Mm-hmm. And it's also really important to try to address broadly applications rather than being too narrow, like you're saying. I mean, we're finding, due to all kinds of macroeconomic forces, that some some manufacturers that we're piloting with in the United States, because we only sell in the United States, they're opening up numerous factories in Mexico. And in Mexico, it's very different because labor costs are lower than in the United States, but they're climbing. The quality is very good. And automation in Mexico is very different than automation, in the Midwest, let's say. And so the ability to introduce a kind of automation that does not rely on a big upfront capital investment and change of an environment, but can just jump into a chaotic, very human-centered workflow is important. And what's shocking to us is those new facilities in Mexico, some of which don't even have a forklift because they see that people are actually much better. So, with more people who are very good at what they do, they're outperforming the places with fewer people with a lot of automation. And so we want to be addressing that with our solutions and, again, augmenting the workers and helping these places become more and more productive. But there is a world where people plus robots is much more efficient than robots with no people. I think we just assume robots with no people are going to do better, but this is all something I can't share. But I mean, there are case studies where more people with slightly less training, with very little automation, are outperforming brand new facilities that are fully automated for manufacturing, like big heavy equipment stuff. So I think, I think we shouldn't take too many things for granted.
Yeah, definitely. I think there's a lot that, there's always the rush to, try to be as efficient as possible, to try to chase the new technologies. And I think a lot of times that can maybe supersede what's actually right in front of you, using your existing workers, your existing facilities, and just maybe not necessarily chasing this brand new technology, but finding a way to incorporate it into your existing system.
Yeah, I mean, I think our approach is really, our ROI is more if we can make certain aspects of manufacturing 20%, even 10% more efficient, and we sell our robots for $17,000 a unit with no NRE, no integration cost. It means that we can provide value in a different way than if we said, oh, you're going to have to spend a few $1,000,000 of capital investment to just get us in place. And then you're going to have to buy the robotics. And, your ROI, I mean, it can look good, but it's a very different proposition with a huge capital investment than with the ability, to buy 10 and then 20 and then 50, without having to make that initial upfront investment and then justify how you're going to make, your efficiency by eliminating people.
Yeah, and definitely being able to, have the technology, have it be readily available, and to kind of let it speak for itself, to prove its value, and then from there to be able to kind of scale upwards.
Yeah. Yeah, there's, virtually no barrier of entry with our robotics because you could buy one or you could buy 100. We have software that helps you manage 100, but it's mostly about over-the-air updates and, pulling logs if there's a problem, things like that. It's not introducing a whole, like space mission type mentality where you've got tons of software that every time you need to make a change, you're going to need an engineer to do it.
Yeah. And one thing I was curious on too is, so there's the two kind of different sectors that these are used in. There's kind of like the personal robots, and then there's the more industrial kind of facility manufacturing based ones. Would you be able to maybe kind of go over the differences between those two?
Well, I mean, to be honest, the differences are in payload primarily. The hardware and navigation and prediction intelligence are frankly the same for both. I mean, we have other features certainly for our manufacturing and logistics robots. That's for sure. But what we built is a VSLAM approach to moving through the world, meaning virtual simultaneous localization and mapping. So we use an RGB camera. We use a stereo camera that builds a point cloud. We use radar just for those situations where sunlight or reflection or transparency would confuse a camera. And with Kilo, which is our enterprise robot, we also add LiDAR, so we can build maps in larger spaces than we could do with our camera clusters. And we have some ultrasonic sensors for just detecting if there's going to be a collision coming from behind the robots and from the sides. So, with that hardware, we fuse those sensors in a very similar way. We don't really change any of that for indoor or outdoor environments, so we can do both. The consumer robots are primarily used by people outdoors. They have a 20-mile range on a charge, which very few people walk with them for 20 miles between charges. The industrial robots, they have a more of a range than 20 miles. And that is a place where you will see a robot in a facility going 10, 20, sometimes even more kilometers per day per robot. So, but again, very similar kind of sensing technology. The obviously the platforms are very different, but in both cases, they're designed to move comfortably with the person. So a person doesn't have to change how they move around the world to accommodate a robot that's maybe too slow or doesn't maneuver well or doesn't have a tight turning radius, all those things. So we're very careful to match human motion as best as we can. And curiously, for our industrial robots, we made them not go quite as fast as the consumer robots. Consumer robots go about 6 miles an hour, and the enterprise ones went 3 miles an hour because we thought, well, they're carrying heavy loads and people don't walk faster than 3 miles an hour. With our first customers, right away, they said, you need to make these go faster. So, like, our teams really like them, but our teams move really fast and they don't want to have to wait for a robot. So, we really try to, with both, match them to human mobility. And then I think what, frankly, I haven't talked about, but what's really makes our company what it is we observe and record multiple people moving around in built environments. And we've been doing that for 8 years. And so we have a one-of-a-kind data set. And we have a very large one, and it's very well curated and structured. So we use a lot of that same data and intelligence and the same algorithms for both kinds of robots because we're figuring out how to move with people, and a person out in the world shopping and taking their kids to a soccer game is the same person that's working in a manufacturing facility. And if we're going to have robots that interact with people, everything we do kind of applies to both situations.
Yeah, and especially in like a manufacturing environment, you have really like heavy changeover. You'll have people swapping shifts. And so you get into much more of a pattern, though, than you might with, kind of someone's day-to-day life. I'm not sure if maybe you've covered this yet, but I guess, when it comes to these robots following people around, how does it determine who it follows?
So when a person is with one of our robots, it detects that they're a person rather than not being a person. Once we know they're a person, we do gesture analysis. So we put a skeleton on that image of a person so we can predict where they're going to go just by, how they're twisting their shoulders, things like that. So we use that to help follow and interact with them. But when other people come into the scene of what we're seeing with our cameras and radar, we also know that they're not that person we're following. So you don't have to wear like a beacon or a QR code on your back or anything like that for our robots to know who they're interacting with. There's always that person, usually at a trade show, who just wants to try to trick the robots the best that they can. The same way if you tried to trick a person, if somebody just jumps between one of our robots and the person that it's working with and just keeps interrupting them and making the view of oblique, sooner or later the robot's just going to stop. And it'll make a noise, and the person that's been working with it'll know that it stopped. And hopefully they would just say to the person, "Would you please stop messing with my robot?" But in a normal use, we just stay attached to the person we're attached to by knowing they're a person, but we don't know who they are. We don't do facial recognition, none of that stuff. And we do that, and then all the other people we know how to interact with. And that includes, like, just as an example, if we're going to avoid, let's say, by the way, our robots follow in front of a person, which for manufacturing, we find people like a lot more. We have the only robot in the world where you can walk towards it and steer it, like with centimeter accuracy, just like if you were pushing a shopping cart, actually more precisely than if you were pushing a shopping cart. Just there's no pushing. You just walk to the robot and you figure out how to steer it as you're walking. And within minutes or seconds, you're already like navigating a robot by walking towards it, and it just steers where you want it to steer like it's magic. And if somebody is in the path of us, diagonally crossing us, or if someone is going to split between that pair, our robot knows whether to accelerate and duck in front of the person or decelerate and cross behind them, because we've recorded thousands of hours of random people in motion capture suits walking together and sending people through them diagonally at different angles and different speeds. And we take all that to build algorithms. So if people are moving with a person in one of our robots, the robot behaves in terms of a collision avoidance the way you would expect a person to.
Okay, so the kind of core, algorithm is based on like how a human would interact in these scenarios.
100%. We even have these very interesting kind of philosophical problems where, let's say, if you're overtaking a person, like somebody's moving slowly with something, and you are trying to decide, is it courteous if I just accelerate and pass this person, even though the corridor is kind of tight? So we'll know that. We'll also know if there's somebody coming towards us, whether we should move to the right or to the left or slow down or speed up. That thing people do where they're walking, where they're passing somebody and they're facing someone and nobody knows what to do, and you kind of go left, right, till you figure out where to go. So, we recorded, again, thousands, maybe even tens of thousands of hours of that kind of behavior of people, put it into our data set, generated tons of synthetic data, built an AI model out of it. And frankly, our robots are better at predicting where to move than people were. And we're like, well, look, in our data, people only succeed like 80% of the time. Our robots are doing it 90%. Do we make them kind of 80% bad just so they feel more human? So in that case, we just try to make them extra polite, because not everybody, we're talking about an average of politeness, and we try to make our robots like super courteous. But we really try to have them behave the way you would expect a person to, just so you don't have to train somebody on what the robot's going to do when you see it in a hallway.
Yeah. Is there any element where, and maybe this is my brain just kind of leaping to science fiction, but is there any element where the robot will kind of adapt itself a little bit to the kind of person that's walking? Like if they're more maybe aggressive, a faster walker, kind of changing the way it navigates?
Well, so, I mean, this might be a time to talk about really the frontier where our company is. Just with our algorithms, our following distance and position is dynamic. And so if there's a person who's a little bit faster or moves side to side a little bit quicker, the robot just does that, changes its behavior because it's got a dynamic relationship to the person in terms of the algorithms. So in that case, yes, they do move very differently based on who they're moving with. When they're moving autonomously, that's where we default to, like, let's say the fundamental values. But even those are dynamic. So if we're moving along autonomously, we also want a robot that's moving autonomously to be polite when it decides to overtake someone who's going slowly. But those overtaking values are also dynamic. So based on how the person that we're overtaking is moving, it'll overtake the person slightly differently.
Yeah. I
Um, we, oh, sorry, go ahead.
I was just gonna ask. I mean, 20 years ago, did you ever think you were gonna be struggling with the question of, how polite should we make a robot?
Uh, yeah, sure. I mean, we really started the company with that because, and it took some time. I mean, in the first few years, if somebody's not trained, I mean, I'm trained as an architect, designed and built a lot of buildings, um, and tend to really think first about the people in the buildings and how they're going to be occupying the buildings. Now, that's very different than somebody who's been trained in data science and, let's say mechatronics, like how to build a robot and think about how it's going to behave, or perception and navigation. I mean, those are very different experiences you bring. And so in Piaggio Fast Forward, we really try to bring all those different experiences together, but with sympathy and awareness of all of those talents. So we're not design led, but we have very strong design thinkers and designers, and a team we call our smart behaviors team, which is really at the very tip of everything. Like, they're figuring out what are the features and functions a robot needs to work with people, so that it's not somebody who's an engineer who says, how many centimeters away from a person do I need to be when I pass them? And I'll just make sure that I safely pass them, even if that means that I move so slowly that I'm annoying or so fast that I scare them. So now those engineers will immediately come to the smart behaviors team and say, hey, when we're overtaking, we need to know how fast and slow and how much clearance and when to start turning and when to finish our pass. Tell us how to make that more human. And then we'll run these studies and generate the data and give that data to the engineering team, who then codes it into algorithms for the robot. So that's really how we work. I think we're very unique that way. What we've done more recently is our AI initiatives were really on that data science and data collection side of things and building these data sets, which we'd use to define the algorithms. A few years ago, we started just handing those curated data sets to our perception and robotics team, and they started to use them in the design of the navigation. And we just recently have a production ready release that we're testing and will start making available to customers, where we have a hybrid system on the robots, which has algorithms for predictability and safety, but it also runs AI models on the edge, meaning on the robot with no Wi-Fi. So if things come up that are, let's say, between some of our features, the robots can make decisions by reasoning on their own. As well, you know, you probably wouldn't notice it, Peter, but to me, when I watch a person moving where they're pushing one of our robots without touching it, and then they stop for a minute, and then they push it a little more, and then they move to the side, and the robot follows them. As I'm watching that, I'm seeing like a switch being flipped between features. I'm seeing following in front. I'm seeing hysteresis, which is when the robot knows it doesn't need to move, it can stop. I'm seeing forward following again, then hysteresis again, then following behind. And when we run that with an AI model, it's like Fred Astaire. Like you don't see the switching between the modes anymore. You see a higher degree of fluidity and I would say efficiency of movement. So it's subtle, but for us, it's really exciting and important. So I also think like coding this social awareness and pedestrian etiquette, and then instead of using algorithms for that, using AI, physical AI, it does open up a more fluid interaction with machines than we've ever seen.
Yeah, and it's especially just to kind of really minimize that gap just become between the human and the machine interface, making it more of a fluid part of the workforce rather than, I have to get the tool, I have to make sure it's following in just the right order. But for it to, really have that ability to kind of blend those features into a single, I think you said like fluid motion and fluid movement,
Yep.
throughout the following process.
Yeah, and it's for us, it's really important that's like, let's say if you had, gloves for gesture and you were conducting the robot, that's one kind of interaction with a robot. But, if you had an assistant and you were working with your assistant, you would not be using semaphore to direct your assistant. You would assume your assistant is smart enough to get out of the way when they should get out of the way and then be right where they need to be when they need to be there. And we're really striving for that version. And again, that's not to besmirch all of my other colleagues, but the general reflex of a building full of engineers is to let's go with the gloves and the gesture and make this as complicated as possible, just because that's really interesting, But it's frankly a lot harder to make it where you don't have to conduct the robot with gesture or voice or any of these things, that it just knows where to be and when to be there because it's like your human assistant. So, but that's really where we drive. That's how we try to drive our technology is more in that direction.
Yeah, and I guess with its implementation so far, are there any like kind of hurdles that you're seeing so far, or maybe areas where maybe people are kind of struggling a little bit to kind of fully embrace that integration?
Well, it's, there's definitely a disconnect. So when people, if you ask someone, what does Piaggio Fast Forward make? Most people in the manufacturing and logistics industry would say, oh, they make AMRs, autonomous mobile robots, like the little Roombas that move shelves and stuff around. And a lot of times when we start talking to people for the first time, their assumptions are that. And their assumptions are like, which jobs are you going to take off of our people? So, and also, how do we need to reorganize our workflow and our space to exploit your technology? So there's a big disconnect, and frankly, that takes some education. We have to get over that hurdle. Once our robots are in place, I mean, the things we hear are just like we want them to go faster. We want them to, maybe be able to follow each other in convoys. So, and those are the things which we just then say, okay, that's going to get on our roadmap. Or we want them to be able to return to base and self-charge. Like, so that gets on our roadmap. So all of those things, are the challenges you get when you start working with customers. But the only real existential hurdle is getting people out of the mode of, I'm going to get AMRs in here so I can eliminate 3 jobs of people, moving goods. And for us to say, no, no, we're going to make the people that are moving goods like 20% more efficient so they can focus on maybe integrating with the other people they're working with for that 20% of their time. So,
Yeah. One thing I'm a little curious of as well is, with your background in architecture, I mean, did you have a big hand in kind of the design of these robots themselves, or was it kind of more so in like the system architecture?
uh, so in the 80s, I was a very early um, adopter of digital technology from the aerospace industry and from the entertainment industry, and thinking about what that would do for how we design the built environment. And very shortly after that, in the early 90s, I was also one of the first people to be able to talk to manufacturing robots. So, for instance, in a big church I designed in New York City, we were talking to the people that supplied the pews for the church. And we found out all of them used the same company in Arkansas who had a CNC manufacturing process, and they would CNC all of the church pews. And so we just called them up and said, hey, we're designing everything digitally. We'd like all these church pews to have a level of customization. If we just send you tool paths, could you manufacture all these things uniquely? And so I was involved in learning how to talk to manufacturing robots and had a lot of CNC machines in my studio and, knew how to talk to whether it's a big KUKA robot, moving components while they're getting manufactured, or just a CNC table that's milling out custom shapes. I got very involved, eventually even working with companies laying carbon fibers in custom tool paths, for strength. So I knew a lot about manufacturing using CNC technology, but my real love is working for people, doing civic things, improving the quality of a person's environment. And so, when I was talking to Piaggio, I was already spinning up a company to make mobile furniture that could rearrange and move itself where it would need to be. And had been talking to some furniture companies that I worked for as an industrial designer about that. And this opportunity presented itself, and I thought I could have a much bigger impact building mobile robots than automating, building robotic buildings, let's say, or robotic interiors. So for me, it was a kind of seamless and natural career evolution, but I think it's probably a very edge case for most people that are CEOs of robotics companies.
Yeah. Was there a bit of a learning hurdle once you kind of found yourself in this position to really kind of delve into robotics? Or I guess, what was that transition like from, architecture to robotics?
I mean, architecture is a very studio structured um, business, and you tend to work with specialists, whether it's structural engineers, you know, people that are doing building systems, people that are doing building envelopes. You don't need to do everything. You just need to know the best people in the world at doing their little part of the problem, and you need to bring them all together and coordinate them. And so, and you need to articulate a clear vision and mission for what you're doing so all of these people with special knowledge can execute to the highest quality possible. So that's no different than Piaggio Fast Forward. I mean, I let people be good at what they do as much as I possibly can, and just try to give a direction that lets us produce something new.
Yeah. And maybe kind of on a higher level, but when you go from, the architecture of, buildings and structures versus the architecture of, a tool or a robot that follows you around, how does the interaction, between the human or the user, how does that change the mentality or the mindset in that design?
Well, I mean, job one is always, no matter what the building type or the context or climate or anything, job one is always learning about how people are going to live or work in the thing you're building. The actual, the details of executing that building and what it looks like is totally secondary to thinking about how are people going to be occupying this place? What do they need? How much space? How do the spaces need to be adjacent and related to each other? How do they relate to the indoors and outdoors? All of these things about how people live and work. That's really what an architect does. I mean, I know everybody says, like, are you really good at math? Sure, but that's actually what you really are good at is people. So people and culture is the thing that an architect needs to be good at. If they're not good at that, they're going to be a terrible architect. So I probably bring too much of that architectural concern to Piaggio Fast Forward, but that is what makes the company different. And it's not just me, it's the founders of the company, it's how we hired and built the company from the ground up. But we really do kind of care about how people are going to occupy the world with our robots. And we think a little bit of our robots as if they're like the people in the sense that they're going to travel in the same corridors and spaces as the people do. They're not going to be in their own little ductwork or their own little painted driving path. So I would say there's more continuity than difference. And that's probably what's the most interesting about the company is how we really think about quality of life and civics and, courtesy of how people move with and interact with each other. Like that's kind of where we start.
Yeah. Well, I'd just like to say thank you so much for joining us here today and, talking about PFF as well as your own career. We really appreciated having you here on the show. Well,
thanks, Peter. It's a little painful for me talking about myself. I like talking about PFF the most. Yeah. It's honestly the most exciting. I've been around a lot of exciting breakthroughs technologically in a lot of different fields. And I think what's going on right now, especially with AI, it's the most exciting time to be working. And it's just really interesting to have these conversations and see where things are going.
Yeah, definitely. And before we go here today, is there anything that maybe we didn't cover today? Anything you'd like to share about, PFF or, maybe as a way to end off, if people are interested in learning more about, PFF, what should their next steps be?
Well, I mean, I hope you see our consumer robots out in your neighborhoods, but all of the manufacturing and logistics kind of data center applications you can't see, which is unfortunate. But we do. I'm just coming back from Modex. It was really interesting to be at Modex in Atlanta just now and see what everybody else is doing, see where the industry is going. So we're regularly at those shows. We'll be at Automate coming up soon. So for sure, come to our booth. You can interact with our robots, walk around with them in the booth and see, talk to our team, see what's going on. I mean, also, we're easy to find at PiaggioFastForward.com. And if you put in /business, you'll see our Kilo robots. So, and, you'll see we have an ongoing partnership with Star Wars and Disney. And so, keep an eye out for our Star Wars consumer robots as well. You'll see those hopefully around.
All right. Well, once again, Greg, thank you so much for speaking with us here today. And I'd also like to thank all of our listeners out there for tuning in week after week. And until next time, we'll see you then.
Thanks, Peter.
This podcast is brought to you by Promise Incorporated. Hosted by Peter Parsons, produced by Lauren Rawl, and mixed and edited by Ben Parsons. If you have any questions or would like to appear on the podcast, please reach out to podcast@promiseinc.com. Thanks for listening.